Inside a modern process plant, two completely different worlds are running at the same time. One world manages your emails, your SAP system, your business reports. The other world controls your pumps, your valves, your pressure, your temperature in real time. These two worlds are called IT and OT. And while they look similar from the outside, both use computers, both use networks. They have very different rules, priorities, and risks. By the end of this video, you will understand exactly how they differ and why that difference matters for industrial cybersecurity. Information technology, or IT, is the technology that manages and processes business data. IT includes the servers that store your company records, the networks that connect offices and remote sites, and the software applications like email, ERP, and business databases. The goal of IT is to move information quickly, accurately, and securely. In most companies, IT systems can be updated, restarted, and patched regularly without stopping business operations. A brief interruption, a server reboot, is acceptable as long as data is not lost. Operational technology, or OT, is the technology that monitors and controls physical processes. OT includes PLCs, programmable logic controllers, that control motors, valves, and safety systems. It includes DCS, distributed control systems, that manage continuous processes like crude oil distillation. And it includes SCADA systems that supervise multiple sites from a central location. The goal of OT is to keep the physical process running safely and reliably at all times. In a refinery, OT is controlling your pumps and valves right now, every second of every day. Here is the most important difference between IT and OT. In IT, the number one priority is confidentiality, protecting business data, securing usernames and passwords, preventing unauthorized access. If someone breaks into an IT system, they may steal data. That is serious. But in OT, the number one priority is availability. The process must keep running. If a pump stops unexpectedly, a refinery loses millions. If a safety system trips incorrectly, workers could be injured. This is why you cannot simply apply IT security practices to OT. A security update that requires a controller restart could shut down an entire process unit. In OT, system availability comes first, always. In IT, systems are patched regularly. Your laptop gets security updates every week. Servers are rebooted every month. Applications are upgraded every few years. This keeps IT systems protected against new cyber threats. In OT, the situation is completely different. A PLC or DCS controller may run for 10, 15, even 20 years without a software update. Restarting a controller means stopping the process. Patching must be tested extensively before it can be applied. Many OT systems still run on operating systems that IT stopped supporting years ago. Windows XP is still common in some plants. IT systems can tolerate delays. If an email takes 2 seconds to send, nobody notices. If a web page loads slowly, it is inconvenient, but not dangerous. In OT, timing is critical. A PLC scan cycle must complete in 1 to 10 milliseconds. A delay of even 1 second in a safety system can cause a process upset or a dangerous condition. Real-time control means the system must respond to sensor inputs and update outputs continuously, without interruption. This is why OT uses purpose-built industrial protocols, not standard IT networks, for the most critical control loops. The Purdue Model, also called the ISA 95 model, shows how IT and OT are organized into 5 levels inside a plant. At the bottom, Level 0 contains the field devices, your pressure transmitters, temperature sensors, control valves, and motors. These interact directly with the physical process. Level 1 is the control layer, PLCs and DCS controllers that execute control loops and safety functions. Level 2 is the supervisory layer, SCADA systems and HMI screens that display process information. Level 3 is the manufacturing operations layer, historians, scheduling systems, and lab information systems. And at the top, Level 4 is the enterprise IT layer, your ERP, email, and business networks. The Purdue Model defines the boundary between OT and IT. And protecting that boundary is the foundation of industrial cybersecurity. For most of industrial history, OT and IT were completely separate. OT systems were air-gapped, physically isolated from the internet and from business networks. This air gap was the main security protection. Today, that separation is disappearing. The Industrial Internet of Things, IoT, connects OT devices to cloud analytics platforms, to remote monitoring services, and to enterprise networks. This connectivity brings real benefits, better data, faster decisions, remote maintenance. But it also brings IT security risks directly into OT environments. Malware designed for IT systems can now reach PLCs and DCS controllers. This is why understanding the difference between IT and OT is no longer optional for anyone working in industrial environments. Here are the 4 things to remember. 1. OT controls physical processes, pumps, valves, heat exchangers, safety systems. 2. IT manages business data, records, communications, and applications. 3. Their priorities are opposite. OT prioritizes availability. IT prioritizes confidentiality. And 4. As OT and IT converge through IIoT, every industrial professional needs to understand both worlds. Understanding this difference is the foundation of industrial cybersecurity.